Hello everyone, welcome back to my channel. Today let's go over a medium level question in the premium category that I just solved on my own. So I'm super happy about this and I'm very glad that I was able to come up with my own solution to this question without any assistance. So let's go over it and let me show you how I did it. So this is question 1152, analyze user website visit pattern. So basically, you're given two string arrays and a timestamp, and basically you have all these users and when they visited a website at the time they did. And then what you want to do is find the smallest permutation and combination in this website list of size 3, where basically you can make sure that there are the maximum amount of users that visited that website in the specific order. So I know that's a little confusing, but as we go through this, hopefully that'll make more sense. So basically, let's create a default dict of type list. And let's go over all the data. So let's go over username. And let's go ahead and map the username to the timestamp and the website they visited. Cool. And then also let's go ahead and sort this by the timestamp because time is in chronological order, so we have to do that. And then now let's go ahead and generate all size 3 permutations of this website. And in addition to that, the parent would be the combinations. So let's call this for C in combinations website of size 3, and then for P in permutations of that C. So now basically we have 3 different websites. So let's print P. Okay, so now we're trying to find how many users visited home and then about and then career in that order. So let's call this 1, 2, 3 is P0, P of 1, and P of 2. And then now we want to go ahead and find that. So let's go over our dictionary and let's count how many users, or let's just call them users and place them in there. So for each key in our dictionary, the now is going to be DKK, which is just going to be this matrix, and we're going to go ahead and find all triplets that satisfy that requirement. So for I in range, length now. For a J in range, I plus 1, length of now, length of now. And these are already sorted by timestamp, so that's good. And then we can just say if now of I of 1, which is the website, is equal to 1, and now of J of 1 is equal to 2, and now of K of 1 is equal to 3, then we can go ahead and add that particular user, right? And then at the end, let's print P and users, because we're trying to find the size of the users, the maximum amount of users that visited that pattern. Okay, so okay, that's fine. Let's go ahead and just make this simple for now. Okay, so you can see Joe, Mary, that lines up, score of 2. And then home cart maps is not even, well, if we go down, home cart maps, I'm sure it's one of these, but that looks about correct. So let's keep going. And then we can just say we want to find how many users. So let's call this the biggest is negative infinity because we want to find that size. So biggest is max of biggest and the number of users, right? Cool. So now let's actually go ahead and append to a sorted list, or append to a regular list. That's fine. And we're just going to append P and then users, right? Because the actual, or we're going to append the combination itself and the users and the length of users, right? Because then we're going to iterate over this, and this is associated with this. So let's go ahead and do that for S and SL. If s of 1 is equal to biggest, then let's print s of 0, right? Because that's going to be what we want to find the lexicographically smallest answer. So let's call this sorted set. And we're just going to add s of 0. And then at the end, the smallest of the biggest frequency means that we can just return answer of 0 at the end because that's going to be alphabetically the smallest. So let's run this. And that's not correct. Okay. Okay, so let's go ahead and make this maybe a dictionary. So let's call this map. So map of, or this might have duplicates, so maybe that's not a good idea. But we can basically just find that, which is strange as to why it's not the case. And let's print biggest. Home about career. You can see that's correct. Because we already sorted by the timestamp. So if this is the website, so that looks correct. That's odd. Let's print C, or let's actually print P. I think it's not supposed to be C because the permutation is actually what we're filtering by, right? So, okay. Okay, cool. So now let's submit it. Because we want to rearrange each combination of size 3. So each subset of size 3. And you can see we get time limit exceeded, and that's fine because there are still ways to optimize this. So let me show you how I did that. So basically, if now of I is not equal to 1, then we can just prune. Same thing here. If now of j is not equal to 2, then we can just prune. Let's try that. Oh, now I of 1, because that's the website. The 0th index was the actual timestamp that we sorted by. Okay, let's submit this. Okay, time limit exceeded. Okay, let's go ahead and make some optimizations again. Let's say if this is in used, then we just continue so we don't have to explore that permutation. And we're just going to add join of P, right? Just a minor optimization. Okay, let's use this test case. Okay, let's submit it. And there you go, passes all test cases. So again, super happy that I was able to come up with my own solution to this question without any assistance and solve it completely on my own. So that's it for this video, and thank you for watching.